Welcome to Team 8's solution presentation to Challenge 8. We're a team of 6 people led by Ryan, including Dylan, Derek, Imogen, Zeshan, and Mo. Our team has a good mix of data professionals and project discipline experts. Challenge overview. Design quality is one of the key factors that determine overall project performance. The earlier in a project that design issues can be identified, the easier and more effective it is to intervene. Our solutions try to determine and quantify key factors and interrelationships that allow us to assess or flag if a project has good or poor design performance. Problem statements. Performance of design process is historically complex to assess. Design success criteria are qualitatively understood but not quantitatively measurable. It's difficult to establish causality between design performance and project success. Each project is fundamentally different, therefore, to find correlations, you require an excess of data. Client statement. As a project manager, I want to be able to understand design quality data and how to correctly interpret it. As a project manager, I want to understand the impact of design quality on my projects. And as a risk manager, I want to be able to predict potential delays or issues within my project from my design performance data. Challenge development. So, to start the project off, we decided to brainstorm KPIs and try and visualize some of the data to see if the data could communicate any correlations. We utilized the software program R as it's a quick and effective tool. We also used Power BI to visualize the data, as this is the tool that CISC use in their portfolio and will ensure easy implementation when the challenge owners take this information back to their business and use the original non pseudonymized data to gain insights into their specific projects. Visual benchmarks. We then developed 6 visual benchmarks that live projects can be compared to, one good and one bad for each KPI. This was repeated by individual contract type, as there are differences in design releases dependent on the construction delivery method. This was done by aggregating the provided data sets and filtering these by performance level and contract type. Therefore, performance level 1 equals bad and performance level 5 equals good became the graphs to compare live projects to. Undertaking the project in this manner allows the solution to become more accurate and predictive, as CISCs add more historic and live project data. Good and bad versus live project. After setting the benchmark graphs, we were then able to compare a single project to them. This was then manually reviewed and visual trends assessed to predict the design success. In this example, we predicted a good project outcome based on the visual comparison. Our prediction was correct, as the performance level previously given to the project was a level 5. Power BI dashboards. We then created a tool to visualize this in Power BI. Although this is at concept stage, the next step would be to include the scripts we wrote in R to analyze this deeper. Further development is needed to interconnect the different KPIs together. Project-wide Power BI dashboards. This will then be further supported by other dashboards summarizing other key metrics relating to the design process. Assumptions and constraints. So project performance may not accurately be correlated with the data provided. Realistic data requires cleaning. For example, the drawing data revision status. We had to assign this into 3 statuses: as built, construction, and design development, as there are originally 74 misaligned categories. We had to infer the program dates based on the available data provided. All data provided was from Reba Stage 5. Design success should be measured over the entire life cycle. To fully capture design success, other key data sets should be included. Phased solutions. So during this project hack, we have completed phase 1 of our suggested solution. We have defined the brief, explored data patterns, established visual benchmarks, and created and proven a proof of concept. Next, we would recommend developing the concept with a statistical approach. This would include replacing pseudonymized data with the actual and complete project data, transforming the visual comparison into a data-driven metrics such as skewness and kurtosis. Lastly, we would move on to automation and iterative improvement, where new data can be feeding in to create a more accurate model using APIs and linking additional discipline data into the design process. Judges, questions. What would you do next? / what's the potential of this if you had more time? As covered in the previous slide, we would continue to progress this proof of concept through to statistical analysis, automation, and iterative improvement. 2. Are the tools configured to provide you with the best data to undertake this challenge? It's not necessarily the tools that create challenges to undertake this project. As the data for this hack has spanned over the last 8 years, we found that some of the CISC's older data didn't correspond to the modern naming conventions or breakdown structure. This meant that there was a level of assumption within our project due to renaming of those categories. Additionally, the tools generally used for design and RFI management have only recently been able to be integrated or linked into other systems. This means that schedule, cost, change, and other data that can directly impact design hasn't been captured previously. Additionally, some of the data that would have been useful has been removed due to commercial sensitivity. 3. What other disciplines could contribute data to improve the accuracy of this predictive tool, and what other function would this facilitate? Cost, change, program, overall subcontractor performance, and many other factors can impact on the design success of a project. The most important of these, which would have been useful to have for this hack, would be client change requests, as this could be a cause for a later influx of RFIs and design documentation submittal, rather than our assumption that late RFIs and design documentation is what makes a bad design success. This could also be useful and help facilitate commercial negotiations of client change, as we would then be able to track the impact that the change has had on the design of the overall project and other factors, such as if this has caused more BIM collab clashes within the impacted area of the change. As a team, we would like to extend our gratitude to Projecting Success and CISC for an enjoyable and educational experience.